Now I'm going to make LED lights. So we can build a simple capsule shape for that. We'll start with a line. And then I will sweep it. Okay, round tube. Increase a bit the columns. Radius. And then enable end caps. Read. Or something like that should be fine. Okay, let's clip the bottom. And then polyfill it. Okay. And that will be our single LED light. Okay. Now let's scatter those. We start with the circle. All right, I'll place it on the ground like that. And increase the divisions to around 50. So what we can do here, we can scatter our points onto the circle. Like that, for example. Let's see what happens if I copy 2 points. I'm copying 2 points. Let's say, for example, that I'm gonna reduce the size like that. So to fill our circle with that, like for example, if I increase the density, you see they're being filled, but at irregular, following the irregular pattern. If you want to make them more uniform, let's say space distribution, you can increase relax iteration, so they're more rigid this way, like that. And then you can increase the total count until it's like this. Yeah, this is one of the ways of doing it, of course. But I would like to show you something different. For example, if you look at the distribution of this lights, even though maybe at the first glance it seems like they're regular, but if you look at it, it's like it's got a certain pattern to it. So there are, it goes into if you look at it as rings, right? So it starts with 1, then goes with 6, then goes like with 12, 18. So it's increments of 6. So I already did the counting, so you don't have to. And when I was researching about this, I found out that this is called radial LED array. It's just very optimized distribution of light. So no matter what angle you look at, it gives you plenty of light. So which is important. And yeah, the traffic lights use this kind of arrays for optimal distribution. So yeah, I just like to recreate the system like that for as an extra challenge, and it's always nice to have this kind of learning opportunities. So when you do when you challenge yourself to do something like that, you learn obviously new approaches and new things. So let's try to replicate this, okay? So for that, what I'm gonna try to do is I will first, let's get rid of this. Okay, transform. I'm gonna disable that for now. So with this circle, I'm going to do the open arc like that. I'm also going to fuse these points because there's one point here that is, well, there are 2 points actually here that are joining. I'm gonna fuse them. Okay, and now I'm gonna use copy and transform to increase the amount of rings. So let's say if I do like 5, 6, and then we will decrease the scale like that. So what it does, it's multiplying our rings, okay? Because I want to copy our LED lights onto these points. But yeah, the way it does it, as you can see, there's no equal spacing here. It's just the math it uses. That's why, without going too deep, how it's using it, but it's not gonna be creating equal spacing between our rings with this approach. So what we can do instead is run it through for each loop. We can actually take this copy. We still keep it, but I'm gonna bring the size back to where it was at 1. So we have 6 copies laying on top of each other here. And for each loop, we will run through each one of those individually and then rescale them, okay? So let's do for each connected piece, connect here. And then let's enable a meta import node. Here we click on that. And this metadata will give us the detail attributes. And we are interested in this one, iteration one. So drop our transform for scaling. Okay, and then in the uniform scale, we can type in detail. Okay, with this detail function, we will just run through each ring with each iteration. We'll rescale it to a certain amount. Okay, so what it's asking us if you look at this usage here, it's asking us for the surface node, and we need to reference our metadata. Okay, so let's look it up. Bridge begin. That should be this one. Okay, then it needs attribute name, so we will type in iteration. Okay, and then the attribute index will be 0. Okay, once we've done this, then we can multiply it. For example, by 0.2. Let's go back to the end. Right, as you can see, now we have equal spacing between those rings. Okay, this is nice. Okay, let's move on. So now we need to copy our LED lights onto these points. But you can see, like for example, our inner ring here has lots of points, and this is not what we really want, right? We want a much smaller amount of points first, and then as it goes up, we have more and more points with each ring increasing, right? So what we can do is drop a resample. And then the resample node, let's go to edit parameters and add spare input. Okay. Should add here at the bottom. And this. So what I'm going to do, I'm going to take this outlet lights null, and I'm going to drop it right into spare input 0. So you see it links it. Now you see we have a link running here. So with this approach, what I want to do is in length, in here, in length, I'm going to use a B box of our LED light. So the segment will be the same length as the size of our LED light. Okay. So let's type in here B box. So we need to reference a surface node. Spare parameter is -1. And then in here, we're going to use the X size like that. So you see our point numbers for each ring change now because it's using the bounding box of the LED light. Let's test it out. So copy 2 points. Add. Also pack. Let's pack an instance. So as you can see, this is pretty much what we wanted to achieve. You know, we can make them smaller as well. But the idea here is, for example, if I were to use this transform or rescaling, you see it's resampling based on the size of the LED light. So gives us effect with each ring. We have more and more incoming LED lights. Okay. So for now, I'm going to disable that. Also, if you don't want them to be so tight, we can rescale it again. So let's use transform, or we can use the primitive properties. This will allow us to transform per LED lights individually, you know. So do transformation. And here we can rescale. Or something like that. Okay. Have a look. So this is the effect we're getting here. Now, I'm gonna smooth them out with the normal. Let's also, actually, since we packed it, let's unpack it so we can manipulate our geometry. Smooth shade it. Okay. Should be good like that, yeah. Gonna rotate. Okay, and then let's fit it into our container. Have a look where we have it. The holder. Go back to this guy here. This was our circle. I'm gonna name it. Okay. Let's do. Okay, let's find it now. The container. Okay, and now we'll fit it inside. We'll fit our lights inside. We can do scale to fit. It fits inside. Also, let's take our everything that we built so far and put it here as well to visualize better, you know. This is our box. I'm just gonna say frame complete. You can also name however you want. So you just understand that it's a full box here that we assembled. Okay. I'll reuse this just to call it again. Frame complete. Okay. So let's see what we're doing here. So with a fit, let's on Z, let's do minimum to minimum. It's placing it inside. Okay, nice. This could be center to center. We are fine with this. Okay. And then what we can do maybe also is to rescale those LED lights a little bit more so they don't, the outer perimeter is not touching the walls here, right? Let's make it a little bit smaller. probably before and here. Okay, let's fix our pivots. I'm gonna center them. Okay, we're in center, and then squish it a bit, like so. Okay, good. I think it should be fine like that, yeah. So we can use this kind of a light for our cars, right? The full one. And on the next part, let's also do the light for our pedestrians, okay? All right, so now let's build our LED lights for the pedestrians. We will do the stick figure with a stop and then go as well. So let's start with the stop, and let's see how we can make it. I'm gonna bring the LED lights. Here. Then I will transform it a little bit. First, turn it, and then make it smaller. All right, then a circle again. And let's scatter some points on it. A bit less. Or something like that will do. And then also let's relax it. Now again, similar approach, copying 2 points. We have a bunch of points here. So I'd like to show you is one very cool node that I discovered recently. So it's called UV layout. I mean, I've been using it for laying out UVs, but I found out it also can be used for packing geometry into it, which is pretty useful actually in our case. So let's plug it. Let's plug our LED lights in here. You see, this is why I have a split screen, because it's meant to be used for laying out your UVs. But here, UV attribute, let's change it to P. You see, now it's packing our LED lights into 0 to 1 space, like projected onto square grid. Okay, so if I was to, like, let's say if I was to change the scale here, See if it makes a difference. Let's say if I were to increase the force total count, you see, it's trying its best to copy those LED lights into 0 to 1 UV space. And the very nice thing about this this soap is that you can also use your custom shapes. So for instance, you can just go ahead and download a stick figure of internet. Can be like PNG image, and you can plug it into UV layout, and it will use it to pack it, which is pretty cool. Just to give you an example, you can use a trace node, right? In my trace node, I have an example. I'm gonna use this trace example. I just made a very super quick shape in Photoshop, with this elephant. And yeah, what it does, the trace, what it does is like whatever you have black, it will delete, and whatever you have white, it will keep. You have this kind of geometry here on the plane. Okay. So now if I were to put in the second input here, okay, I'll need to go to the targets and then change to islands from second input. And then also UV attribute, change it to P. Okay, let's see if it works. Okay, so as you can see, it's taking our lights and filling the elephant with it. Okay. In our case, I would like to build my own stick figure because I want to have like a fine-tuned control. So I want to be able to move its hands, move its legs, feet, and so on, so I can adjust it if I wanted to. But as I said, feel free to just use a trace node and use a stick figure PNG file, if that's working for you. I'm just gonna build my own. So for now, I'm gonna delete this trace and concentrate on building very quickly the body. So let's start simple with the head. Circle. I'm going to lay it on the ground because it's going to be easier. Z explain. Reduce the scale. And also the divisions, bump up the divisions. Yeah, that will do. Now let's move on to the body. Use a grid. Make the body elongated, like so. And also reduce rows and columns. And taper it a little bit. Then I'm gonna use match size. And we'll do minimum to maximum. So it at the bottom of our head. So we're left with this. Okay, so now for the arms, I'm gonna use a polygon curve. Polygon curve. I think I'm gonna do just like 3 points, because it's gonna be easier to control. So we can bend later on, you know, if we want to, we can bend the arm. Okay, so now 3 points, hit enter. That, and then you can go to edit mode here. Now, you know, I can just move these points if I wanna bend our arms. So let's have a look at our reference actually. So yeah, we have like you see the arms are symmetrical with the legs as well, so it's good. You can use a mirror sop. And then let's make it curvy, the arms. We can resample it. Change the polygons as subdivision curves. And let's say we want maximum segments, like 10 is fine, you know, so it's like this. You can adjust it. Say arms. Okay, I'm gonna do another resample. This time, or maybe even better, no, better idea would be to use sweep. So let's do sweep. That will give us some thickness. We can go for the ribbon. And then we don't need so many columns. Let's keep it to just only one. That's the thickness of our arm. And also let's enable the end cap. Grid. Like this. Reverse cross section. And can move it like more or less like this. Okay. Now I'm gonna mirror it on both sides. Nice. Okay. Let's merge it. We have this. Then we can just reuse this this bunch of nodes for our legs. Merging again. Okay, now let's move them down. Sometimes like geometry gets reversed, but don't worry about it. It doesn't really matter because UV layout doesn't care about that stuff. All right. So let's say these are our legs. And then let's do the feet as well. Feet. Okay. So here, And then move them down. I'm thinking, you know, like for the feet, these are very large feet. And for the feet, we can only keep like 2 points. We don't need 3. And also we don't even need to resample really. You know, something like this will do. Make them a little bit smaller. Like that. Then we do something like that. Okay, so now let's have a look if we can plug it into our UV layout and what's happening there. Let's bring it over. It's still using the elephant. Let's go back. Rectangular. Again, islands from second input. So if you see, like if you use the island from second input and nothing is happening, it's because the UV layout's got this, it's like a quirk that if your mesh is laying on the ground, it won't do it. It needs to be perpendicular to the floor. So we will need to rotate our guy. Oops, sorry. That's not what I meant. Transform. Rotate 90 degrees. Okay, and also let's center it. The center. Okay, and now, yeah, now it's working. Good. So it's filling our shape. See, there's lots of LED lights here. So if you would like to reduce it, what we can do is to play with the packing option here. So change from maximum to fixed. You can see with the fixed one, there is a scale that you can adjust, like to fit how many really, you know, you want to fit in. And what happens is like it tries its best to fit our shape, and whatever is left over, it arranges it into like infinite line. This is our leftovers. Obviously, we don't want them in our shape. So what we can do here as well is in output groups here, just tick non-packed polygons, and we will blast it away. Unpacked. So we just left with our guy like that. Okay, so in here, what else we can do? Let's see. We can play also with the rotations, different degrees. With the island padding, that's the separation between our LED lights, how much padding there is. So we can make our lights a little bit more separated. So we can push it like to, let's say, to 20, something like that. Also, there's a little hidden advanced option. So with the advanced, you can increase the resolution of your packing. See, it does a better job of packing, maybe. And then, yeah, so with this, you can just play, with the positioning of of your curves, just to achieve the result that more or less you want. So what you can do is you click on the initial curve input in here, and this is if you start like moving this. Let's see, click on those guys. Now you can start adjusting your arms. So to make it a little bit more user friendly, what you can do as well is just temporarily transform your stick figure so it roughly matches with your curves. Let's say we can lay them on the ground again. Let's see, where's our curve? Oh, our curve is here. Let's just enable it. And then we move our guy in here. Like that, okay? So now I can go back to my curve and start making adjustments. I'm just clicking on those points and move my arms around. And do something like that. So yeah, I'm just gonna I'll adjust it a little bit until more or less like matching my reference. Doesn't need to be exactly the same, but like roughly matching it. Yeah, I think something like that. Maybe later on I'll do a few more adjustments. So let's delete that. We have our stick figure. And then let's repeat the same process like we did before. We can just copy this, guys. Let's feed him into our container. Put it inside. Rescale it a bit more. Like that. Okay. And we call it pedestrian stop, let's say. Okay, so then this will be a red stop pedestrian LED lights, and I'm just gonna do offline exactly the same, but only for the walking with the green, because I don't want to really waste your time. It's gonna be exactly the same. I'm gonna copy this over, and then just move the some of the points for the legs and arms, so it's kind of like walking. Okay, so I'll see you in a bit.